So we're not going to waste any time here. I'd like to invite Professor Theresa Jones up to give her presentation on taking animals out of the spotlight, the challenges of mitigating light pollution.
Thanks. Thank you. Now, let me see. So apparently I point here, counterintuitively, yes. Before I begin, I'd like to acknowledge the Wurundjeri, Woiwurrung and Bunurong people of the Kulin Nation as the traditional owners of where we are today, but more importantly, where the majority of the research that my lab conducts. I pay my respects to their elders past, present and emerging, and I warmly welcome any Indigenous peoples here today listening to my talk. I hope I don't offend in any way. Right, I'm going to press my button because I'm a waffler. Good. So I'm here to talk about mitigating light pollution, and so what I thought I'd do, because I'm often told that my talks are quite depressing, I'm going to start with a good news story, and I'm going to talk about perhaps what the gold standard in mitigating pollution, and that's CFCs. CFCs are chlorofluorocarbon gases, easier to say when you're not nervous, but in 1928, Thomas Midgley created Freon. This was the first one. It was really important because what it did was revolutionize our ability to refrigerate. It allowed refrigeration. It did other things too, but let's focus on this refrigerator. By the 1970s, CFCs were in widespread distribution. 1 million tons were being emitted per year, and up to 500 million was being contributed to the US economy alone. We'd already started realizing that CFCs might be not quite as good as we thought. There was a hole in the ozone layer, which was problematic, and scientists were making grumblings about whether this was potentially a contributing factor. In 1973, Sherwood, Rowland, and Mario Molini published a paper theorizing that these CFCs used in refrigerants and aerosols could be depleting stratospheric ozone. By 1976, the National Academies of Science confirmed the negative impact. Congressional hearings were happening, and federal government started exploring this. In 1987, the Montreal Protocol on substances that deplete the ozone layer was signed by 198 separate entities, states, countries, the European Union. 14 years between basic research stating the problem, we get assigned one of the largest and most significant international treaties was signed, or at least protocols. As a consequence, CFC emissions have decreased massively over the last 50 years. Now, CFCs have an unfair advantage. There is not a single pollutant out there, I'm going to argue, that has the same advantage that CFCs had. And that is replacing them was relatively cost neutral. Because even before we realized the problem, new chemicals, new gases were being produced that could replace with impunity the gases that were there. We could produce bigger and better refrigeration systems. If anyone's had the misfortune of having to buy a new fridge, you know that they do everything nowadays. Mine has a compartment called Prime Fresh in the refrigeration section. I have literally no idea what it's supposed to do. What it does in actual fact is freezes randomly, rendering most of the things I want to eat inedible. Now, it is still bigger and better than it probably would have been in the 1950s. Importantly, though, because bigger and better and replacement was possible, this means that cost-wise, businesses, manufacturers, think about anyone benefiting from this, didn't lose money. Importantly, the vast majority of consumers probably didn't realize that they'd got a new product. They didn't complain about the replacement. Because of these two things, laws could be signed with impunity, and this is hugely beneficial. So let's talk light pollution. Let's follow the same pathway. In 1879, Edison's invention of the incandescent light bulb happened. By the 1930s, we were already recognizing the importance. I'm talking biology, apologies, physicists. I know that you thought about this years before, but I'm going to focus on biology for this one. By 1987, the International Dark Sky Association was created. In 2005, possibly one of the most important contributions at the time in terms of ecology was published. In 2007, WHO declared that light at night and shift work was potentially carcinogenic. years before, the 2016 American Medical Association, as we've already heard about blue light, published a paper declaring blue-white light being a risk for cancer and diabetes. 2019, ADSA was formed, in no small part due to Marnie's contributions. 2019 plus, and we've already heard about this today, there are a number of countries introducing laws to protect the night sky. I'm going to suggest that they're probably not as concrete as they need to be, and there's quite a lot of wiggle room within them. And in 2020-21, the National Light Pollution Guidelines were published. Over the last 30 years, there's been a massive increase in the amount of publications on light pollution. We now have 600 plus, there's 4,000 plus articles, the science backing up the impact of light pollution. And yet in 140 years since the introduction of the light bulb, and more than 20 years since ecological light pollution was declared as problematic, we haven't really gone very far. So let's talk about science, and I don't think a day should go by without recognizing contributions far and wide. This is what a certain person said about climate science. I know, I'm sorry, it's funny. I'm going to talk about one half of the scientific picture. I'm not going to talk about the other one. I'm going to talk about the actual science. So let's think about that first. What we know about light pollution is it's up to about 20% of landmass now, and about 30% is spilling into our coastlines. We've already seen some fantastic talks that have covered this. Its growth is anywhere between 6 and 10% annually. Importantly, from our perspective, nearly 30% of vertebrates and over 60% of invertebrates are nocturnal. Their activity is during the night. 30% of threatened species live in our cities. That's significant. And light spills from our cities can be seen, well, we see, 180 kilometers away. I'm going to go slightly less than that. This is an image taken from Serendip Sanctuary, which is about 50k from Melbourne. And that is indeed Melbourne pre-changeover to the blue-white LEDs. You can see how yellow it actually is. What we know about artificial light is it changes the physical properties of the environment. It's increasing nocturnal brightness. It can change the color of the light, of the night, sorry. Importantly, though, it masks natural transitions in light. It doesn't turn night into day, but what it does is it masks two really important places, and that's dawn and dusk. And it applies that light, that constancy of light chronically every single night, every single week, every single month of every single year. There are lots of different conglomerations of work. This is a publication that I was involved in, and it's nice because we were fortunate enough to get the cover as well. And this cover shows you some of the impacts of light at night. The artist was a little bit liberal, but we'll go with it for the purposes of today. It shows you lots of things that we can actually see. We can look at this willy wagtail, normally day active, nocturnally capturing what was supposed to be a moth. It looks more like a butterfly, but the artist was very certain that that's what he wanted to portray. We can see that it's disrupting movement and activity. It's altering foraging behavior. It's disrupting sleep. It's turning night into dusk all night. Something you might not think about is it's fragmenting the environment. You can see that light is partitioning dark spaces. Rather like cutting a swathe through a forest, light is cutting a swathe through the darkness. It's like a form of habitat destruction. And importantly, and we've already heard about this, it can hide the stars. Important for us culturally, really important, many species use celestial bodies to navigate, to form a lot. Fuck, really? I've got 20 minutes, haven't I? Have I not got 20? Oh, okay. Sorry, I apologize for swearing, by the way. That was totally inappropriate. There are lots of things that we can't see, and our knowledge of the aquatic environment is relatively poor. The science is good, but many people are not studying it. Broadly, though, light pollution is chaining nocturnal pathways as well. It's affecting globally protecting areas, so it's quite broad in its effects. Oh, thank God. Can I just say that swearing was justified? Thank you very much. Right. can I just quickly go back then, even though we've covered it? So there's a bunch of stuff we cannot see, and actually the thing I wanted to point out are two things. One, the microbiome, which we're going to talk about today, those changes in hormones we've already heard about. But importantly, what we can't see are the species that have left, and that's important. As I said, the aquatic environment, Mariana's going to cover that later on today. So, broadly, changes in nocturnal migratory pathways of birds, bats, potentially insects too, and that's really important. We've heard already about the bogum moth. There are some other reasons why that may have been influenced, but light may be a contributing factor. As I said, light pollution is affecting those globally protected areas. That spill that we talked about means that those point sources of light are now affecting the places where we're trying to protect nature. That's problematic too. More broadly, and probably because of all the things that have come before it, light pollution is implicated in biodiversity declines, not just vertebrates, but invertebrates. As ecologists and scientists, we're really worried about our pollinators. It's big business, big economy, but it's also really important in terms of our ecological networks. They have a massive function in our ecosystems. If we lose them, we are in a lot of trouble, not just in terms of the beautiful things that we will lose, but our agriculture depends on it. So let's look at lighting. We know we've got good science. We know that light pollution is really bad. But there are lots of costs. We don't have cost neutrality when it comes to solving this problem. And in fact, we have not bigger and better, but we have three options for replacement. We cannot replace like for like, but we can do one of three things. The first we can do is lower intensity, starting with 0 as your starting point. You know, do we need light? Then move forward. The second thing we can do is change the colours, and we've heard about this today. Blue reduction is something that is proposed as wildlife sensitive. Actually, while I'm here, can I make an advocacy for wildlife sensitive and that no one uses the term friendly? I will not be a happy woman. The third way that we can do it, and again we've heard about it today, is we can shift the timing. We can create dark refugia during the night. Or during sensitive periods of the life cycle. But the problem with all of these things is that they are costly. All options are costly in some context. Consumers notice, and that's a problem, because what that means is that we cannot sign laws or other things with impunity. It differs from those CFCs. More importantly, though, the science tells us that only one of these will actually solve the problem, and only one little bit of one of these, and that is 0 as a starting point. So let's look at the science, because we can't just go with our gut, despite what Donald says. Lower intensity 0 as a starting point. We know that a luminance of less than a full moon applied chronically every single night still generates disruptions to our behavior and physiology of a wide range of species, but also their communities and those interactions that I've just talked about. Different colors are important, but life on Earth has evolved to maximize 4-dimensional space. It's not just in terms of everywhere around us, but it's also temporal space. And so we need to somehow accommodate that. After 4.5 billion years of evolution, and we're trying to accommodate how this multitude of species has filled that space with all its spectral differences and their spectral sensitivities. No single color shift is going to be good for all, and much as we want to get rid of blue, that's not necessarily good for all either. And finally, we can shift the timing. Censored lighting is optimal, and we can have dark refugia during the night. But what part of the night should you keep dark? We often turn off between 11 and 4. Fabulous for us, but that misses dawn and dusk. And that's some of the most critical periods that we have. The issue, of course, is that mitigating light pollution relies on us balancing with human conflict. Thank you, that's much better. I've got 5 minutes. Light is lovely, we like it. I work on light pollution and I look at that and go, it's kind of nice. Light is there, let's make no mistake, to benefit the nighttime economy and to benefit our own activity. That is why light is there. This is my kids' footy ground. That's the full moon rising in the background. Light is there to protect us, to keep us safe. We know that bad lighting is not good, though. We also know that bad lighting doesn't, or lighting in it per se, doesn't necessarily make us safe. There are some beautiful studies out there that have looked at this specifically. I think Tim Hunt is going to be talking from Arup, and they were part of this study. We also have a global shift to LEDs. We've talked about this today. So we're shifting from this yellow to this blue light. Overlaps perfectly with our own visual spectrum, so we can see really well. But it also happens to overlap with what we call our circadian spectrum. You have non-visual receptors in your eyes that perceive different colors of light, and they're super sensitive to 480 nanometers blue light. So this overlap that we now have with LEDs is even stronger than it were before. Now I'm going to propose something. Most of what we've talked about and most of what I've heard today is anthropocentric, putting humans at the center of our science. Could it be that our own biases are influencing our choices and decisions? Are we putting our own preferences onto the world around us? Of course we are. But does it matter? There are challenges with mitigating light. Lighting standards focus on human vision, and there's very little attention even now to ecological impact. And there are few maximal limits. The key problem is that lighting responsibility is diffuse. It's across so many ranges of government and consultants, developers, and there's often not clear guidelines. It's problematic. There are opportunities, though. There's scope for improving lighting and carving out for ecological sensitive areas. Thank you. New amendments are a marginal improvement. They're still not perfect. We have lots of guidelines now. In fact, any of these provide an unbelievable wealth of resources. The science is all within them. Strategies, ways in which you can move forward are in many of these different either websites or documents. This is the village that started all of this. This is Siding Springs. I recognize many of you from that conference. And it represents a range of people. And it does take a village to raise a child. I Googled this, African origin, possibly. I'm going to argue that it takes many villages to tackle light pollution. And I genuinely don't think we're going to solve this problem. Mitigation is what we're going to do at best. I asked ChatGPT, and she was very forthcoming about what we needed to do to mitigate. And these are all the different groups. I apologize if you're not there. I put them on a map like this, but you can see that each one has a single arrow. Actually, that's not what it should look like. It should look like a web, an intricate web with every single person connected to every single person and every single entity operating as a conglomerate. That's how we tackle light pollution. I'm going to end where many people have already talked about, and that's with the EMU. Because for me, it represents a really nice acronym. E, eliminate. Turn off lights when and where we can. Start with zero. Start with zero. That's your conversation. Mitigate. We know you can shield lights, reduce the glare as much as possible, make sure they face down, change timing, color, and intensity. It won't solve the problem, but it will help mitigate it. And the final thing we need to do is understand. Assessment is critical. That's what we do as scientists. But I think what's important when we're thinking about mitigating light pollution is that you need to have a knowledge of who you need to convince and a knowledge of their priorities. Honestly, that's what I've learned in the many years that I've been working in this in the past 10. I've been improved by the people I've spoken to much more than the science I've conducted, because now I have a deeper understanding of where we all need to be. I'm still not sure where we need to go, but I know where we need to be. I'm going to end by thanking my village. It is quite extensive. My students in particular, 2 of them are going to be talking today. They ground me and they provide me with the excitement and the desire to keep on in this, and I thank them for all their contributions. I have a lot of collaborators and government and industry and also funding bodies who, if they want to give me more money, I'd be super excited. I finally thank you all for listening. Thank you very much, and I'm happy to take questions.
Thank you so much, Theresa. I really enjoyed that optimistic walk through history and look forward with the EMU approach. I think we can all take that on board during this symposium. I think we're actually out of time for questions, but please come and find Theresa at the end of this session if you have any questions for her.